What is aerodynamic drag coefficient in automotive performance? Imagine driving down the highway and feeling the wind push against your car. That push is caused by air resistance, which can slow you down and use more fuel. Today, we're going to uncover what the aerodynamic drag coefficient really means and how it impacts vehicle performance. The aerodynamic drag coefficient is a number that shows how much air resistance a vehicle faces as it moves forward. It is a ratio that does not depend on the size of the vehicle, making it a useful way to compare different shapes. A lower number means the car is more streamlined and cuts through the air better. This means less energy is needed to keep the car moving at high speeds. In automotive performance, the drag coefficient is very important because it directly affects the force that opposes the car's motion. This force, called aerodynamic drag force, gets bigger as the car speeds up. The faster you go, the more the air pushes back. The drag force can be calculated with a simple formula. The drag force equals half of the drag coefficient times the frontal area of the vehicle times the air density times the speed squared. This formula shows that reducing the drag coefficient or the frontal area helps lower the drag force. When the drag force is lower, the engine doesn't have to work as hard to keep the car moving. That means better fuel economy and higher top speeds. For example, a sports car with a very low drag coefficient can reach higher speeds with less power. From a mechanical engineering point of view, making a vehicle more aerodynamic involves shaping it to reduce turbulence and pressure differences. Cars with teardrop shapes have very low drag coefficients, around 0.5. Most everyday cars have values between 0.25 and 0.35. Larger or boxier vehicles like trucks and buses tend to have higher drag coefficients, often above 0.8 because of their shape. Reducing the drag coefficient can lead to real benefits. It can improve fuel efficiency, helping drivers save money on gas. It also allows cars to go faster and accelerate more quickly. Race cars often balance reducing drag with creating downforce, which helps them stay glued to the track. Road cars mainly focus on lowering drag to save fuel and reduce emissions. In the end, the aerodynamic drag coefficient is a key number in automotive design. It helps engineers understand how shape affects air resistance. By working to lower this number, they can make vehicles faster, more efficient, and better suited for both racing and everyday driving.